Elastic collisions, that's when the two objects hit each other, but they don't stick. Like they bounce off each other. If you have elastic collision, we have two things. We have conservation of linear momentum. We also have conservation of kinetic energy. Now, let's see how that works. We have a cart here that has a mass of 2 kilograms. Moving this way, velocity of 4 meters per second. Collides with another cart. Pick a mass for it. How heavy you want it to be? 5? You want it moving or not moving? Pick direction if you want it moving. 2.
Moving left.
Moving left. How fast?
2 meters per second.
This is before they collide. Obviously, you can see they're coming toward each other. They're going to hit each other right there. This is the after. They're going to bump each other, but this is the 5 kilogram. This is the 2 kilogram. Do we have any idea which way they're going to move? Do we have any clue? Not really, so we can take a guess. We can say, you know what, I think this one is going to continue moving in this direction. I don't know. Or maybe they'll hit and they go backward. Who knows? So I'll use this. We'll call it V1. And maybe this will go backward, V2. This cannot continue to go forward. Because if it continues to go forward, that means they can't. Physically, they can't. You're going like this. How are you going to continue moving backward and forward? There's no way. They're either going to bounce back like this, or they're both going to go this way, or they're both going to go that way. These are the 3 possible ways. I can make them bounce back and each one going backward. It's possible. You know? Maybe I'll do that. And since I don't know, I say, you know what? I'm not sure what's going to happen. Let's assume they're going to hit each other and bounce back. Could be. It's a possibility. So this is the before. This is the after. I'm assuming, I'm saying, not assuming, I'm saying they didn't stick together. So we have elastic collision. Elastic, that means we're going to have conservation of linear momentum, conservation of kinetic energy. So let's look and see. Let's look at conservation of linear momentum. Is that the heater, the noise? It sounds like it. Let's look at the initial one. We have the 2 kilogram going to the right to what velocity? Positive 4, right? Add to it the 5 kilogram, not grams. Going which way? Left of negative 2 is equal to, the way I drew my arrows here, the 5 kilogram going to the right, that's plus V1, plus the 2 kilogram going left, that's a negative V2. Eight minus 10 equals 5V1 minus 2V2. Negative 2 equals 5V1 minus 2V2. That's equation number 1. conservation of linear momentum. Anytime you have elastic collision, we say we have conservation of linear momentum and conservation of kinetic energy. Let's look at the kinetic energy now. Here we go. The kinetic energy before should equal the kinetic energy after. The kinetic energy before is 1/2 the mass, which is 2, times the velocity, which is 4 squared, plus 1/2 the mass, which is 2, times the velocity, which is, mass is not 2, the mass is what, the second one? 5, right? What was the velocity? 2 squared equals 1/2 the mass 5 times the velocity v1 squared plus 1/2 the mass, which is 2, times the velocity, which is negative v2 squared. If you want to make life easy on you mathematically, notice since the 1/2 shows up in every one of them, you can just drop it. Mathematically, that's fine. That's multiplying the whole equation by 2. So I don't have to deal with the 1/2s. So this will be what? 5v1 squared plus 2v2 squared equals 2 times 16, which is 32, plus 4 times 5, that's 20, that's a 52. And that's equation number 2.
Would that be minus 2?
Because you squared,
Oh,
right? That'll be a plus. You square on the minus, that's a plus. So that's equation number 2. Now I got 2 equations by 2 unknowns. Physics is over. Now it's math. And that's where the math gets ugly. If we take equation number 1, if I take this one to this side, that becomes a plus. Which means V1 equals what? Negative 2 plus 2V2 divided by 5. Substitution says solve for one of the variables, which I did in the first equation. Now go to the second equation, plug it in. (52) equals 5 times V1. In place of V1, I'm going to write negative 2 plus 2V2 over 5 squared plus 2V2 squared. Square them. When you square this, you get a 4 that multiply it by itself. That's 25 in the bottom. So what's negative 2 plus 2V2 times a negative 2 plus 2V2? What's negative 2 times a negative 2? 4. Negative 4V2. Negative 4V2 plus 4V2 squared. So I'm going to have 4 minus 8V2 plus 4V2 squared. Now, by 5, this is 1. By 5, this is 5. I could eliminate all the fractions if I multiply the entire equation by 5. Five times 2 is 10. 25 and 1, 26. That's 260. Equals. The 5 cancels the 5 there. 4 minus 8v2 plus 4v2 squared. And 5 times 2, that's what? 10v2 squared. Clean it. 10 and 4 is 14. Minus 8v2. When I bring this number to this side, it becomes a negative minus what? 260 minus the 4 is 256. I can divide by 2 to make the number smaller. 7v2 squared minus 4v2. 256, that would be 128, I think, if you divide by 2. How will you solve this one? Well, I can't factor 7 out because it doesn't have it. What is it? Yeah, quadratic formula. As I said, the math gets a little bit ugly here. Here's the bad news. This is 2 equations by 2 unknowns. If you're dealing with 2 dimension, it becomes 4 equations by 4 unknowns. I can use the quadratic formula here. A equals 7. B equals negative 4. C equals negative 128. And the quadratic formula says if you're solving for V2, it's going to be minus B plus or minus the square root of B squared minus 4AC, the whole thing divided by 2A. That'll be 4 minus a minus, that's a plus. Negative 4 and square, that's 16, minus 4 times 7 times negative 128, all divided by 2 times 7, which is 14. That'll make it a plus. Let's see what that number is. 4 times 7 times 128. 4 times 7 times 128. I got an error the first time. 3584 plus the 16. 3600. You got to be kidding me. Notice we just picked up the numbers, and what's the square root of 3600? 60? So 4 plus or minus 60 over 14. One solution for V2 is going to be 4 plus 60 over 14. The other one, 4 minus 60 over 14. 4 plus 60 divided by 14. 4.57. And the other one, 4 minus 60 divided by 14, negative 4. Remember what V1 is equal to. Where was it? 2 pages back. What was V1 equal to? V1 was, where was it? Negative 2 plus 2V2 divided by 5, right? So when V2 is 4.57, let's plug it in and see what V1 is. So negative 2 plus 2 times V2, which is 4.57. Make sure you hit the equal sign to get a number first, then divided by 5. That's 1.43. When V2 is negative 4, what's V1? Negative 2. So here are my answers. One of them physically does not make any sense. We'll see which one. So this is one group right here. This is the other group. Let's draw the picture just to remind me, because I forgot even what the story is. Okay. Here's what I have. Let's look at the first answer. This is going in this direction. That's the 2 kilogram. It's moving to the right at 4 meters per second. This one, the 5 kilogram, moving left at 2 meters per second. If I grab this answer,
Where did you get the 1.43?
plug it in. Plug the 4.57 there.
I'm getting 2.22.
Nope. You got to make sure you get the number, get one number. That's 4.5 almost times 2, that's a 9. 9 minus 5 minus 2 is what? 7. 7 divided by 5 is almost 1.4. Yep. I said this is what's going to happen. I indicated V1 is going to the right, and this is going this way, V2. This one, the first answer says, yep, V1 is, this one is going to go backward 4.57, correct, in that direction, and this is going to go backward in the way we drew it, correct, 1.43. It's possible. So that could happen. Case number 2, let's see if that's possible, the negative 4 and the 2. Case number 2, it says, no, you're wrong. This one is going to go forward with 4 meters per second, continue to go forward, and this, you're wrong too, is going to continue to go what? Backward at 2. The only way that will happen if there's a hole in them, to keep going through it, like a bridge. And if there's a hole, there's no collision anywhere. So that answer does not make any sense. Physically, cannot happen. Go ahead, Mike.
So for the answer is for V1 and V2 where they make sense. So we completely don't pay attention to the positive and negative that we assign for.
Well, no, this one it says when you get to plus here, we did pay attention to plus and the minus right here, Mike, when we plug them in.
Yeah, when we're finding the actual value.
No, when you get the value after, this one says 4.57 says your direction is correct. That's what that means.
So they both should be positive.
If
Both V1 and V2 should be positive if it makes sense.
no, it could be negative actually. I'll give you one where it's going to say you're wrong. It should be backward.
Okay.
So I'll give you one now. So no, you got to look at it. It says this one. It says 4.57 to the left because I made it to the left. The fact this is a plus, that means my direction is correct. So my assumption saying this is going this way, 4.57, and that's going that direction of 1.43. Yep. Did you get that answer, Jason?
Yes.
Okay. Let me try one where I'll make sure the number come out negative and show you what that means. We might be able to do one problem. Notice they take a long time, these problems. They're not a 1 minute problem. Let's take pool. playing pool there. And I don't know the mass of them, but I'm not even going to give you the mass. Identical balls in pool. All the balls are identical. So you struck this ball here, a velocity of 10 meters per second. It hits this one here, which is now moving. This is the Q one. Doesn't have a number, the Q, right? This is number 7. The Q are called Q. How is that? The Q ball. Let's say right dead on. Because otherwise, if you're on angle, it's going to go in 2 dimension. I don't want to deal with 2 dimension yet. So I have no idea what's going to happen. So I'm going to make the assumption here that this one is going to go backward or forward. I don't know. You decide which way you want it to go.
The 7 ball?
Well, there's the 7. The 7 has to go one direction. We know if you played pool, which way? Probably to the right. Called V. V1. What about this one? Do you think we'll go backward, forward, continue to go forward? Okay. V2. So we're making the assumption they're both going to go forward. The 7 will go much faster, and the 2 will dribble right behind it. So this is the before you hit the ball. This is after. Actually, you're going to find out if you played pool, this one probably going to stop, and this one goes forward. If you hit it dead center. But let's see. Conservation of linear momentum. I never give you the mass for any of them, but they're identical masses. You'll see why. So mass times velocity. What was the velocity of this? Positive 10, right? Plus the mass of the number 7 times the velocity, which is what? 0. Equals the mass times what? V1 plus the mass times V2. And what do you notice? Every term that it has what in it? It has m, right? Which means you can just divide by m, and they cancel each other out mathematically. 10 plus 0 equals V1 plus V2. 10 equals V1 plus V2. That's one equation. Again, this is conservation of linear momentum, conservation of kinetic energy, elastic collision. The kinetic energy before equals the kinetic energy after. The kinetic energy is 1/2 m times 10 squared plus 1/2 m times 0 squared equals 1/2 m times V1 squared plus 1/2 m times V2 squared. And everyone has 1/2 m in it. I can just cancel them out. What is 10 squared? 100 plus nothing is 100 equals V1 squared plus V2 squared, and that's my second equation. 2 equations by 2 unknown. Since there's no fractions here, the math will be easier. Here's my 2 equations. Let me just write them down. V1 plus V2 equals 10. The other one, V1 squared plus V2 squared equals what? 100. we solve for V1 here? 10 minus V2. So come back, replace V1 now with 10 minus V2. Plus V2 squared equals 100. What is 10 minus V2 when you square it? That's multiplying it by itself, the FOIL method. A lot of people want to square this and square that. Doesn't work that way. That's 100. Negative 10 V2. Negative 10 V2 plus V2 squared. That'll be 100 minus 20 V2 plus V2 squared. If you subtract 100 to move everything to one side, gone, gone. So you have what? 2V2 squared minus 20V2. The easiest way to solve this, I won't even use a quadratic formula, that's too much work. You can factor 2V2 out. If you factor 2V2 out, what's left? 1V2 minus the 10. Now you're multiplying two things, your answer is 0. For your answer to be 0, that means one of them has to be 0. V2 will have to be 0. V2 will have to be 10. Again, when V2 is 0, let's look at this. Can we find what V1 from that equation? What is V1 will have to be when V2 is 0? What is 10 minus 0? Isn't that 10? So that's one group of answers. The other one, when V2 is 10, you plug it in. What's 10 minus 10? Is that a 0? That's the other group of answers. Let's see if it makes sense physically. Where's my picture? This is how I drew my picture. This is the Q going this direction of 10 meters per second. It hits the 7th pole, has no velocity, and I'm claiming that the Q will continue to go in this direction of V2, and this one, the 7, will go in that direction of V1. Let's look at the first answer. This group of answers. Physically, is that possible? Saying when you hit it, this one says this one is going to have a velocity of 0, which means what? It's not going to move. And what's going to happen to this? It's going to move forward 10 meters per second. Absolutely possible. If you played pool, you know that. This one says, you know what's going to happen after you hit it? This is moving with 10, this is not moving. It's going to continue. The Q will continue to move at 10 and this doesn't move. There's no way. Unless that's made out of gold, which is heavy. And even if that, this will not continue to move. This probably will not move, but it might bounce back, this one. But this one's saying, that, oh, this will continue moving just like nothing happened. They never hit each other. We know that's impossible. So if they're the same size and one is moving, it hits another one. Usually if you hit them dead center, the one that's moving will stop and the other one goes forward. Now if they're different size, like bowling, you get the ball hitting the pin. if something bigger hitting something smaller, this is a bigger one hitting something smaller, and this is not moving, I don't know, 5 meters per second, for example. What will happen after the impact, we'll call them 1 and 2. This, the bigger one, will continue to move forward. And the smaller one will go forward at a much faster pace. That's normally what happens if you hit them dead center. Both of them will continue to move forward. If they are the same size, and this is moving at 5 meters per second, and this is not moving, if you hit them dead center, the one here will not move, will have a velocity of 0, and the 2 now will have a velocity of 5 meters per second. You saw that in that bowling there, in the pool. And if a small one hits a bigger one, and this is going this direction, 5 meters per second, and this is not moving, what will happen actually, because the small one hitting that, the bigger one has to go forward. You're hitting it, it's going to go forward slowly. But guess what is going to happen to the smaller one? It's going to go backward. That's normally what happens. These are the 3 scenarios. So if you remember that when you're trying to guess which way they're going to go, you can make life easy by going, oh, I know, this is a bigger one hitting a smaller one. They're going to continue forward. Just think of it if you're playing bowling. The ball much heavier than the pin, so when they hit, you see the pin goes flying, and the ball continue to go forward. So that's what will happen. The pin will move forward at a much higher speed rate there, and this one will follow going forward. Just like if a truck comes in from behind you and hits you, a big truck, you're going to go forward, so as the truck continue to go forward. On the other hand, if you come in from behind, hit a truck that's not moving, there's a good chance, well, not a good chance, well, if it's elastic, assuming otherwise, because you probably stuck together, but if the bumper is made out of some rubbery material, is going to bounce, you will bounce backward. You'll go backward, and the truck will go forward at a smaller rate. But you'll go backward much faster rate. Yeah. And if they're the same size, this one will just stop, and the one in the front that will stop will move at the same speed. So those are the 3 scenarios that normally happens. If you get a 2-dimensional one, we got a problem, because you'll have 4 equations by 4 unknowns. And that's not fun usually, unless we give you some of the pieces. If we give you some of the pieces to make the math easier, then that's not bad. I'll go one example, then we'll call it quit. I am actually glued to that stupid game curling. When I see it on TV, I have no idea what the rules are. It looks like a shuffleboard, but I see them knocking the, I know your goal to get as many of them in the circle, and they're knocking, but I watch them play, and the masses are the same for them, so that makes my life a little bit easier. I don't have to give you a mass for them. But let's say we're curling here, and somebody hits the ball, it's moving, of the velocity here, 1.5 meters per second. And instead of hitting the ball dead center here, there's another ball here, looks like this. And this one is not moving, has a velocity equals to 0. So what's going to happen after the impact? After the impact right there, you will see, we'll call them 1 and 2. You will, because 1 is hitting the 2 on the top there, you'll see 1 go in that direction. And you will see 2 go in that direction. And to make life easy on us, let me give you a few things. Otherwise, you're going to have 4 equations by 4 unknowns. None of us wants to solve 4 equations by 4 unknowns. Let's assume we know the velocity of this one, 0.61 meters per second. And we know this angle to be 66 degrees. Can we find the velocity of this one? We'll call it V2. And theta, we'll call it theta. Can we find what the velocity and the direction will be? I can call it V because that's only really V there. Instead of V2 y subscript, just call it V. Can we find the velocity of the second ball in theta? And the reason I gave you this and that, so to make the math easier. Instead of 4 equations by 4 unknowns, we have now 2 equations by 2 unknowns. Otherwise, if I didn't give you these, you're stuck 4 by 4 solving. It could take about an hour. X direction. We'll use this way, positive. Y direction this way is positive. Let's look at the first one. What's the mass of this? M. What was the velocity? In the x direction, 1.50 squared, right? I'm doing conservation of linear momentum. Velocity, now, no square. So the momentum before equals the final momentum. In the x direction, what do we have here? The mass, which is m. What was the velocity in the x direction here? 0. After the mass of this, m, times the velocity. What's the velocity of this? .61, yep. Cosine 66 degrees, right? Plus the velocity of this, which is what? V times what? The mass times the velocity. The mass, m, what was the velocity? V cosine theta. Notice everyone has m in it. .5. Let's see what that number is. 0.61 times the cosine of 66. 0.25 roughly. 248. I'll go 25. Plus V cosine theta. 1.25 equals V cosine theta. Again, I try to make life easy on me. I don't have to do 4 equations by 4 unknowns. What about the y direction? In the y direction, the mass of this, m, what was the velocity in the y direction? 0. Plus the second one, the mass m, what was the velocity of this in the y direction? 0. The mass of this, what was the velocity in the y direction? 6.1 sine of 66, right? It's positive because going upward. Plus the mass of this times the velocity of this, which is what? Negative V sine theta. Why negative? Because the y value pointing which direction? Down. So the velocity is down. Everyone has m in it. Zero equals 0.61 sine of 66, 0.56 minus V sine theta, or V sine of theta equals 0.56. I don't even have to use conservation of energy there, kinetic energy, because I have two equations by two unknowns. I'm done. If I didn't give you these two, then I will have two equations by four unknowns, and I have to use the kinetic energy before equals the kinetic energy after. And I got to do it in the x direction and in the y direction. That's where the four equations. But here, because I gave you these numbers, I shrunk that to two equations by two unknowns, because I wanted the math to be quick. So let me write my equations now. V sine theta equals 0.56. V cosine theta equals 1.25. And again, anytime I have a problem like this, the quickest way is divide by each other. If you divide them, gone. Tangent theta equals 0.56 divided by 1.25. 0.56 divided by 1.25. 0.448. And to get theta, you gotta use the inverse tangent. Second 10, 24.1. And now we can solve for v. Grab either equation. V sine theta equals 0.56. We know theta is 24.1. .56 divided by sine 24.1. 1.37. Again, if I didn't give you the two values on the top, we could be here for another 15-20 minutes, easily. Because you'll have four equations by four unknowns, substitution, and go through it. You might see that on the homework. I hope I put them on the homework where I didn't give you any value, so we can tackle that tomorrow. Okay.